Guys, they're here. What's that?
What are we doing? Are we like reviewing or are we looking over something?
We're reviewing. Yeah, okay. So, this is from, your quiz review packet. So go to page 7, read, number 3, it's on page 7, try this. And then I'll, walk it by with you. It's still like.
Oh, is this the review? Yep.
Yeah, quiz review. Other than you. Which I think
It's hard. Maybe.
but I'm not.
Like all you need to do is know the. I'd say the only part that's semi.
The quiz will look like worksheet 3,
Oh, that's like the one that I went on first.
page 11, 12, and
That's
13.
actually huge.
So if you can do that, it should feel good.
Okay, that's actually huge because that's the one I did. How many pages is it? It's probably like one or two.
Yeah.
He only applied to my
Sit, just 3.
Then you got rejected.
No, you got it.
No, you got it.
Yeah,
Who did?
he risked it all.
Who did?
Some dude.
All right, guys, go ahead and start. I'll give you guys 5 minutes to work on it, and then I'll go over the problem with you. We'll do that for each of the problems, 7, 8, 9, and 10. Let's start. Page 7. Thanks. Okay, part A, top minus bottom, just area, so remember that with area, we don't square whatever we create, so just make sure we don't overdo it, right? That we just do top minus bottom and then integral from A to B. There's no squaring here. If we square it, then it's something else. Then you're either doing cross section or you're doing with physical washer method. To come out to be 18. This is not on the quiz, but this is a non-calculator on the AP exam. So if it's not a calculator, then we're forced to have to go through all this work. But on the quiz, you can just plug all this and plug this in the calculator.
That's all we have to do is get the integration.
Yeah. But for now, I do want us to practice this process, right? I don't want us to forget power rule and evaluating upper and lower bound. On the AP exam, a problem like this could show up on the non-calculator section or on the calculator sections. If it's in the calculator section, typically the problem is would require a calculator because it's not easy to evaluate, but this one is meant to be non-calculator because we can work it outside here. Hey, part B. Right, but do not evaluate the integral expression that gives the volume of the solid generated when R is rotated around the horizontal line. Anytime you see the word rotation, you know it's got to be disc or washer method, right? That rotating uh, process will create circular shapes, and that the process that they're circular shape will be either disc or washer method. And then from there, to decide between washer or disc, we look at that dotted line to see, is it up against the flat surface of the shaded region? If it's not up against the flat surface of the shaded region, it'll always be washer method. So this method is very restrictive. We've got to have no gaps between the shaded region and the dotted line.
So if it's like a parabola where only the vertex is touching the axis of rotation, it's still like, is it still washer method?
It's still washer method because it's not a flat surface, right?
Okay.
So if it was this, that's still washer method, right? So unless you have a flat surface touching touching your axis, it'll always be washer method. Part B, our dotted line, our axis of revolution is off of the shaded region. There's obviously a gap, so we have to draw. We know there's going to be washer method. There's going to be a hole that we got to subtract out. So from the axis to the furthest region, that's going to be our big radius. From the axis to the closer of the two regions, that's going to be your little radius. And then we just do top minus bottom for each of these, right? The top of big radius is sitting on the dotted line. The bottom of the big radius is sitting on the 2 root x. Then we identify our bounds. Our bounds is from 0 to 9. Everything that we see is in terms of x. Part B is only asking for you to set that up. So we can stop here for this problem. Part C, go ahead and try part C and I'll go over it with you. So part C is cross section. Cross section is taken perpendicular to the y-axis. So we're always going to be told exactly how to draw our base. It's either horizontal or vertical, but instead of saying horizontal vertical, the problem is always going to represent it this way. It's always going to say either parallel or perpendicular to the x or to the y-axis. And in this case, this will be horizontal because y-axis is vertical, perpendicular is going to make it horizontal. So it's a horizontal a base, which means we have to spend the time to rewrite our equation. Our equation is not going to be in the proper form as it stands. So the y equals 2 root x needs to be written as x equals y squared over 4. Our other bound is our y-axis, which is x equals 0. We do right minus left, which ends up being y squared over 4. Now the height, they tell us the height in relation to the base. They say that the height is 3 times the length of the base. So since my base is y squared over 4, my height must be 3 times y squared over 4. So if I have my base and my height, I know that I can multiply them together to get to my rectangle because a rectangle's area is base times height. So once I have my base and height multiplied together, I just have to get to that third dimension by involving the integral and the bounds from 0 to 6, because that's the lowest and the highest y value of my shaded region. Okay, any questions? All right, next page, page 8. By number 4. This is also meant to be non-calculator, so see if you can work this through without a calculator. There's a little bit of use substitution involved here. Top of my rectangle is sitting on the x e to the x squared. The bottom of the rectangle is sitting on the negative 2x. Subtract them. To work it out by hand, we have to go through a little bit of use substitution for this first piece here. U value is the x squared. Evaluate, go through use substitution, cancel out the x's, with the 1/2 left over. And now, once we have the antiderivative for x e to the x squared, 2x becomes 2x squared over 2. Going to power rule, plug in the upper and lower bound. Part B. Find the volume of the solid generated when R is rotated about the line y equals -2. So anytime you see the word rotation, we know that's going to be disco washer method. this is a non-calculator section on the AP exam. They will never ask you to do something as complicated as this. So typically, if it's a physical launch method problem, unless it's simple enough, they're going to just ask you to leave it in that form.
Why is it down from 1 to 0?
Because we go from the furthest left to furthest right, so from 0 to 1.
Oh,
So if everything you see is in terms of x, your bounds have to be in terms of x as well.
the bounds not in terms of y for top to bottom.
Hmm?
Are the bounds not in terms of y for top to bottom one?
Only for left to right. Okay, yeah. So we're stacking these these circular rings from this side all the way to this side. So we're stacking them this way. So we're from 0 to 1. What's the sign that you have to use 62 for part A? Um, So we know we have to go through u substitution because we don't have a rule that can handle xe to the x squared. But if we go through u substitution, then we can make it turn into something that feels more familiar because we have a rule for this. And we're working our way towards that. But on the quiz, you can just plug this in the calculator. I wanted to show you what a non-calculator on FRQ could look like. Okay, page 9. It's xe raised to the x squared. There's no e in the exponent. Oh, it's just x squared. Okay. Yeah. Yeah, cool. I just promise. Yeah, come on. Right, part A, we're just finding area, so top minus bottom.
Wait, could you do right minus left for this?
Yes, you could. But typically, we want to try top minus bottom first, and if that doesn't work, then if we're forcing the right minus left, then we do it. But typically, um, we prefer right top minus bottom if they give us that option. But yeah, right minus left can also work for this problem. Part B is cross section. But what's a little bit different about part B compared to other cross section is that normally we have to build the area, right? We have to get the base, put the base into some area formula, whether it's a triangle or rectangle or square or semicircle, and then we can put the integral state notation around it. But in this case, they make the problem a little bit easier for us because they already tell us what the area is. So we should put the integral around that area. We don't have to build the area because they're already giving that to us. Because cross section is just the integral of the area accumulated from one end to the other. Right? But typically in the past, we would have to, I mean, for part C, you're going to see you got to build the cross section itself. But for part B, the cross section is already provided for you. The area is already provided for you. You just have to set it up and work it through. But this is non-calculator, so there's a bit of u substitution that goes along with this process. Zero to two. We do x values. Now, part C is more of a traditional cross-section problem because now we can build a base because they're telling us which orientation to build the base and what area to get out of it. So this one, we're forced into a right minus left because we want the base length to be perpendicular to the y-axis, so it has to be horizontal. And because it's horizontal, we have to spend the time to rewrite our equation in the proper form. So x equals root y for the curve, then x equals y over 2 for the linear. We do right minus left, that's our base length. Once we have our base length, we graduate it to the area formula. So base squared is this formula for a square. And then once we have our area, we move it up another level to the volume component by putting the integral notation around it from 0 to 4, because the lowest y value is 0, the highest y value of the shaded region is 4. Okay, try part D. Part D says find the volume of the solid rotating the region R around the line x equals -1.
It's like negative is it possible for something negative, but
No, because if we always do top minus bottom, we're always guaranteed that whatever we get back in return is a positive value.
so if the whole graph is negative, would it just be the one that looks like it's on the top, either top or like numerically?
Yeah, the one that's on top. But if you mess up for some reason, you can just change that negative to a positive because that means you just got the bottom and the top mixed up. You don't redo your work, you just change the sign. Yeah, so ultimately it's not a huge deal if you got the order wrong because you can just change that sign to a negative or a negative to a positive. Okay, part D. We can reuse a lot of information from part C. We're rotating around a vertical line, which means our radius has to be horizontal. Because if our radius is horizontal, we know we are doing right minus left. So we can reuse the equation from part C. We can also reuse the bounds from part C. Just have to build out our radius, big R and little r, to set it up. Okay, page 10, last one. Part A is just area, so just top minus bottom. A little bit of U substitution with that cosine of pi over 4x. Part B, rotation. Now, if you look at this entire shaded region has no flat surface, so no matter where our axis is, there's no option but washer method for part B. There's no way we can make with the shape of this figure, there's no way that any axis of revolution will create this method, so. No matter where that axis is, there's a gap, we'll have washer method. Part C is a cross-section problem. So we find that base length, adapt it into the area, and then put the interval around it. Okay, any questions? Okay, so tonight, make sure you look over your notes. Page 14 has all the formulas that you need to know for the quiz. So area formula for top minus bottom or right minus left. This method, washer method, for either vertical or horizontal axis of revolution. And then also areas formula for cross sections. Most everything is base squared. You have to memorize the coefficients that sit in front of the base squared for the different shapes. I encourage you guys tonight as a final review to work through page 11 through 13. Your quiz will look a lot like this, 3 pages. So use this as your mock quiz tonight if you haven't already done so, and check your work. I won't be available tomorrow morning. I'm doing a help session for my AB students, but I will be available this afternoon. If you have any questions, you want me to go over anything, I can do that. And I'm also available 5th period lunch today. Okay. All right, can we get your phones?
On JC.
Like the big one, isn't it?
Yeah, on the big guy. Great. Anyways, okay, on thing.
Oh, I were. What?
On thing is down. Anyways, on religion. On religion. The cross central time. When you multiply on
I'm done.
Oh,
You don't give up this. Then you drink money. I have $150 in Monopoly money. Okay. You have drink money. I'm doing bad, bro. You don't have money in your lunch account. Huh? You don't have money in your lunch account. I just burned out lunch account. We could, bro.
I saw what it said. Mr. 32 in English language. Yeah, I believe you got it 42.
That's good. You do? Do you have your drink? I asked for it, I'll pay you back. I'll pay you back.
What drink do you want?
Mr. What? Mr. Pitt. Okay, because you do not do that. I think it's just the pin. Yeah, I don't think it's. Wrong thing. Doctor.
Wait, if you can pay me back, why don't you just pay them for the fees?
No, I don't have money to talk. You guys are saying
Can I, like a year or two, can I put interest on this?
I'll pay you back next semester. I'm paying back next. I'm paying everyone back next semester. No, I owed Jameson like $12.
Nathan, do you have any questions with cross section?
Yeah, I had a question actually. Oh, yeah. I was gonna ask. Versus the area one, right? So you told me it was 2-0, right? But I was not. Okay, hold on. So you said for area it would be 2-0, correct? But this was, this is right minus that.
What is how my bottom?
But I squared is not.
This is actually becoming. I've never done. I used to never do this. That's the only reason why.
No, it's not. You're right. It's 2x minus. So that's how my bottom.
Yeah, if I was to do right for you. No, like we passed that class with this 4-0.
Yeah, but then your equation has to be in terms of y.
Yeah. So when y'all still cross, like what? Do the review or?
We did a problem research.
Which I, yeah. You take a free value, just say, oh, but it's like.
This test.
No, this be after.
Because I don't know, I think the thing, but it looks like
Trigonometric function,
Yes, that's right. Yeah.
polar function.
The password is Milton. I'll send out.
That's valid though, that's valid.
Like the one.
I'll send out that. So.
and is this on every
It's very specific.
What's the part where you like have we finished AB by the end of the year?
Yeah. All of AD, which is kind of going back and kind of.
Yeah, matrices, we learned matrices, like last year, we learned matrices, fraction, division.
Yeah, we did that, like,
Getting like a 9 on quest. I literally, on Monday. And I just like, I came to school, took the quiz, went home, and that was my last day. Yeah. Some shit like I like low-key did, he never got to tell my like.
Letting us ask who's cross section.
And it's like built. I don't know how it's really weird. Everyone has a different last day depending on what you like need to get done. Like everyone has the same official last day. They come in
The area.
something like that, or you have to, yeah, like
Sign.
okay, if the teacher has assigned a quiz.
That's my.
On like Monday, then Monday's your last day. You just come take the quiz.
Okay, yeah, that's cool.
Hello, this kid. Yeah, I just.
Huh?
Right, so this is now my.
Yeah. Do you know about virtual days?
Now cross section, we're just taking this and then putting the area. Move on. Where?
I've already used up like some
Where? Formula. Equal amount of triangles, like one half the square. That's one. Now we take this. This whole thing and put it in a formula.
They'll not like, they'll let you not. Then because that's like.
Yeah, this area. So to get to that volume component.
Okay, and these now, might be why it goes to why, because.
Yes, but
But that like, I'm looking at your variables. You have nothing to like focus on other than.
Like, if this was right by now, then that would be why.
That's right.
Just give. It's like about a year, yeah, I'll bring your plans, but not.
why balance?
Like, allegedly, he didn't want to. I don't know, like, yeah, it's not that bad with the calculator, but when you see the like small things on the computer scale.
What do you plan to do?
I can through.
Yeah.
11 through 13?
Yeah.
Okay.
Either today
I'm like finally good at.
yeah, that's like English is the part of the like part I get like math the part that I actually.
I like how you said that one.
Oh, wait, it's
Push my answer. And again, I gotta still make a deal. I'm not gonna get 100.
Okay. Let's see, I was gonna ask you a question, please. Unlike a cross section problem, if it asks like, I'm gonna be able to calculate Nathaniel axis, does that make it like? When you take the. That's wrong. On a lot. I put the. Yeah. So then this is this one. So then the integral would be in terms of x, yeah. I don't know.
Does he get it?
I'm getting 100 on the quiz. I'm calling it right now.
Oh, this one.
Good.
Ron's,
I'm raising at 30%.
I think it's like snowboarding, like that's so funny. Like, girl, like, what are you talking about? I did the Yamaha thing. It's fine. It's fine. You'll be fine. You'll be fine. I just need to wait. And then I'll be like,
Here are all the ones. Everything's
Yeah, are these derived by the like?
Yes, yeah, so I've already derived this, you just have to memorize the coefficient.
Sure. Okay.
5 or 8.
Just take the integral.
So sure. 0 is 0. Yeah, if I factor that out, it's 2 squared is 4, 4 is just 8. So yeah.
Yeah, okay, perfect. Okay, thank you so much for that.
Also, if you have any questions, you're not gonna hear back from me after. I'm gonna be out.
Okay,
Sorry.
okay, no.
He's not until tomorrow.
Yeah, yeah. No, it's next stupid for you.
Like the quiz is tomorrow, right?
It's tomorrow.
Yeah, I feel fine. I feel like I know all the concepts. I just have to sit and like do all the problems.
Yes. Yeah.
Okay, thanks.
Have a great day, guys. See you guys. Bye.
You do find me very. Is acting.
Yeah, we did it.
And how we're on that.
First, we stuff like, it didn't have anything to do with the small. Hi. Oh, yeah.
Here is words. He has like his whole house. What else do I have? I'll read it. Like that.
Oh, you might want to.
Yeah, I was like. Yeah.
Or what we did on.
No, it's got last. He has like.
But it's not gonna be on the computer. Well, unless you're ever keep talking. Why is it?
Oh, yeah. You did page 1 and page 3, but I'll cover this after.
I heard it's right here. Oh. I can't explain why. Yeah, that's how you want. Yeah, I'm used to getting it always. I want to do soup. I want to see it.
Sir, you get our quiz with you.
I'm sorry.
We can get through our calculators.
But we're doing some FRQs that are not calculators, just to practice all of our steps that we just had to use. So I know the same record.
It's not.
I could win. Just, I need Jake Percy to go to me. Oh, yeah. You got it.
Did you see it? Oh, you're getting shocked. All right, guys, go to page 7 in your quiz review packet. Was anyone else not here on Friday? Didn't get a packet? Anyone else here Friday? That's good. Okay, guys, go ahead and read number 7. Page 7. Go ahead and read the problem. Go ahead and try it, and after a couple of minutes, I'll go over each part with you. Our goal today is to work through page 7 through, I think, page 11. All these are non-calculator. Just wanted to kind of show you what the non-calculator FRQ looks like. But on the quiz tomorrow, you'll get to use the calculator, so you don't have to show any of the steps after the setup. But here we are doing a little bit of power rule or use substitution to get to our answer. After 5 minutes, I'll go over this problem.